In the previous video, we have integrated our A-star algorithm into the candidate map and checked that it is working. We need to tackle another issue. Let's increase the number of pieces and let's play the game. So we have no path here because there is no way between those 2 points. So now we need to tackle this issue where we need to delete some of the obstacles for the path to be available to us. And that's what we are going to do now. So let's go to the candidate map script. Let's slide down and let's create a method called public list of vector3 called repair. And we do not need to return this list of the repaired cells, but we may want to in case we want to do something with those spaces. Anyhow, let's call int number of obstacles equals, this is the number of cells that actually contains obstacle. So we need obstacles array. And we are going to use link library. So let's type where, Alt Enter, and we should be able to say using system.link. And we are going to check if the cell or maybe obstacle is lambda expression is obstacle, so it's true because we are getting each boolean value from our obstacles array. And we want to only get those which are true, so we can get its count. And this is the number of obstacles that we all have on our map. Now what we need to do is to prepare a list, vector3s, and this is list of obstacles to remove. Equals new list of vector3. Great. Now we will check if our path dot count is less or equal to 0. So let's say we have calculated the A-star algorithm path and we want to call the repair method anyhow to just see if we can fix it. And this is because we will be calling repair automatically and we do not want to run it if we have already established a path on our map. So if we have the path, there is no need to run the repair method. So if the path.count is less than 0, let's call do, and we are going to perform a removal of random obstacle while, and in do statement, find path after every removal, and we are going to check do while this.path.count is less or equal to 0. So basically, we are going to remove obstacles as long as we do not have a path. Okay, so how are we going to remove our obstacles? We are going to call int obstacle index to remove equals random dot range, and we are going to select a index from 0 to number of obstacles. Okay, now we need to loop through our obstacles array. So for I equals 0, I less than obstacles array dot length I plus plus. So if obstacles array dot I index is equal to true, so basically if this is true, if this is an obstacle, if obstacle to index to remove equals 0, basically we want to remove this concrete obstacle from all the obstacles. So we are going to loop through each obstacle and we are going to count them, and when we reach our random obstacle to remove, then we are going to remove it. So if our obstacle index to remove is 0, we are going to set obstacles array of index I to false. And we are going to add to our list of obstacles to remove, add grid calculate coordinates from index I. Okay, so and we are going to break because we have removed our random obstacle. If not, we are going to subtract 1 from our obstacle index to remove, so from our random number, until we reach the index of our obstacle that interests us. So basically our obstacles array has I think 121 spots when we set an array of 11 by 11, or our grid 11 by 11, and we want to remove the 5th obstacle. So we loop through each obstacle array field and check if it is true. So we eventually get the first obstacle, the second obstacle, and let's say we want to remove 5th. So we subtract 1 from obstacles index to remove. So first we remove 1 from it, second, third, 4th, and 5th. And on 5th, our obstacle index will be equal to 0. And if it is so, we are going to remove this obstacle. And that's basically it for this algorithm. And after every time, we are going to find the path. So this is one thing that is a little not optimized, because if we do that, we might be calling it very often. So in this spot, we could optimize the removal of our obstacles. So maybe instead of obstacles, we will remove knights one by one. And after we establish the path, we retrieve the knights and obstacles that are not part of the path. So it would dramatically reduce the number of calls to A* algorithm. Now we should be able to call this method. But before that, we want to re-add some of the obstacles that doesn't belong to our path. So for each var obstacle, in our list of obstacles to remove, and here we are going to want to check if our path contains the obstacle. So this is not an obstacle, this is actually the position. So let's call it obstacle position. So if our path contains obstacle position equals false, so it doesn't, we are going to call int index equals grid calculate index from coordinates position dot x position, sorry, this is obstacle position dot x obstacle position dot z. And we are going to call obstacle array of this index is equal to true. So we are going to replace this obstacle. And at the end, we can return our list of obstacles to remove if we want it. Actually, we can delete it because we do not need it for now. So there is no point in returning this. So instead, let's return void. Great. So now we have our repair method ready. Let's call it if we want to automatically repair. So you might remember that we have called create map and passed to it Autorepair. So let's call if Autorepair. We want to call our repair method. Great. And of course, we could have a button to do just as this thing. So let's check if our repair is public. Yes, it is. So let's go to our map generator. Okay. And now we can return our obstacles to list of obstacles to remove. So we might want to return a Boolean value instead, because what we will do now is we will call repair. So if in our create map we pass Autorepair Boolean value as true, so if Autorepair, we are going to call repair. And if it is so, we do not need to do anything else. But what happens if we want to repair map using a button, for example? So if we want to auto repair, it will perform repair for us after creating the initial map. To visualize it better, let's go to map generator And let's create a method that will be able to call using a button from our custom inspector to regenerate the map, to repair the map on a button click. So let's create public void try repair method. Great. And we will want to check if our candidate map, and we do not have it. So let's expose the candidate map we create here. Let's expose it as the variable of our class. So private candidate map. Okay. And we are going to check if map is not null. Then we will be able to call on it map repair. And we will want to return var result equals map repair. And if result is, or maybe let's, instead of result, let's call it list of obstacles to remove. Okay, this will be much more clearer. And if obstacles to remove dot count is greater than 0, then we will want to regenerate our map. So to do that, we are going to call our map visualizer dot clear our map, and we are going to call the same method that we are calling here, map visualizer visualize map using the grid, the map return data, and false, we can call false here. Great. And now let's go back to the map generator inspector that we have created a while ago. Okay, and here we can copy this if statement, paste it below, and let's change the name of the button to repair map. And instead of map generate new map, we are going to call map try repair. So we should be able now to click this button and the map should be regenerated. So let's go back to Unity. Let's press play. Great. And now what we can do is click repair. And we can see that some of the obstacles were removed to create a path between our 2 points. And that's exactly what we have wanted. So that's great. And now that we are sure that our map has a path and can be repaired to have a path, we can return the data and we can update the map data to return our path, and we can visualize all of that using prefabs. So that's what we are going to tackle in the next video.